So our warm-up today, we have a regular hexagon. They had to tell us that it was regular or we wouldn't be able to solve this problem. So regular means all sides congruent and all angles congruent. So how would we start this problem? Where would we begin? There are no numbers on this warm-up. At A, angle A, very good. Okay, so we would start by using one of our handy-dandy formulas, which, by the way, you need to memorize before Friday. We're not giving you the formulas, you're committing those to memory, okay? So, this one is n minus 2 times 180, and then divide it into 6 parts because there's 6 angles. And V says that A is 120 because 4 times 180 divided by 6 is 120. So all the angles of this hexagon are 120. And from there, it is easy, huh? It's like a domino effect. We'll find everything else from there. We're going to do linear pair. Ooh, what kind of triangle is that? Yeah, you were trying to type it really quick. It's an equilateral triangle because if 2 of the angles are 60, well then the third angle is 60. And then D is the linear pair of 60, so it's 120. How'd you do on that warm-up? Yes, it's equiangular and equilateral. Yes, good. Easy, simple dimples. Oh, I don't think I've heard that one before. How was last night's homework? Good, bad, tricky, easy? I thought it was fun. I like this homework. I like the little tricks. Okay, starting with number 9, we know that ABCDE is a regular pentagon. Sorry, this is bugging me right here. Okay. Since it's a regular pentagon, we know how to find each angle. We do. We have a formula for that. There's an app for that. There's a formula for that, right? So, the formula is n minus 2 times 180 divided by n. It's 3 times 180 divided by 5. You know how to find the angles of any regular polygon that we give you. So when you do that formula, you're going to get 108. 108. Each angle, the whole angle, is 108. Here's the cool part that I like. Now we're going to look at triangles. We're going to go from polygon to triangle. A triangle is a type of polygon. If you look at this triangle right here, we know something about that triangle. We had to use our prior knowledge in our brain to realize, wait, if this is a regular pentagon, then all sides are congruent. Tick mark, tick mark. Well, if that triangle has 2 tick marks, it's an isosceles triangle. Very good. We know that in an isosceles triangle, the base angles are congruent. We learned that on Monday. The base angles are congruent. So y and that other angle, they're the same measure. So 180 minus 108 and then divided by 2. So these angles are 36. 36, 36. I could do the same process on the other side, on the right side. 36, 36. I know that angle D, I know the whole angle is 108. So if I do 108 minus 36 minus 36, I get 36. So that angle was actually trisected. Is that a word? Bisected is a word. I'm not sure if trisected is a word. Cut into 3. We couldn't assume that from the beginning. Maybe we could because it was regular. But we use other pieces to show that it really was trisected. Well, now it is. Now it's a word. Okay, so 36 was the answer to those. Let's look over here at this one. In this one, I would start with that 30-degree angle and the fact that the triangle is isosceles. So if that's 30, then that's 30. Ooh, that triangle is not isosceles. It's more than that. We just offended him by calling him isosceles. It has double tick mark, double tick mark, double tick mark. This is the key to the problem. That's not isosceles. That's equilateral, equiangular. That means every angle is 60. 60, 60, 60. And this problem just got easy. So 60 minus 30, that means this is 30, 30. And now we can find y. If we've got a triangle and this is 30 and this is 30, we can all find the missing angle. So 180 minus 60. 120. All right. Next problem, number 12. If JL is 5, then ML is... Now, we're going to have more tools to solve this problem today, but if you just used your best guess, which you're not really supposed to assume, right? You're not supposed to assume. But because this is isosceles and because that's an angle bisector, it actually does cut 5 in half. So this problem is just 5 divided by 2. It's 2.5, and I can show you other reasons today why that's true. Okay, last one, 18. Okay, let's get this one. In triangle ABC, A is congruent to C. So the first thing you're doing is you are drawing a picture. Every student is drawing a picture. A, B, C, where A is congruent to C. If AB is 4x minus 6, BC is 3x plus 24, and AC is 3x minus 15, find the length of AC. This is a classic, we gave you too much information, don't you dare use it all problem. That's what it's called, officially. No. In this problem, you're not going to use all three of those. You're going to use the ones that matter. You're going to use the legs. The legs are always across from the base angles. The legs in an isosceles triangle are congruent. So we know that 4x minus 6 equals 3x plus 24. We know that x equals 30. So we did not use the 3x minus 15 yet. We ignored it. The base cannot help us find the legs. So now that we found x, all we do is plug it in, 3 times 30 minus 15, and boom, we have the length of AC. So instead of x here, you're going to put 30. Oops. And now that problem's over. So the key to that problem was not trying to use all three of those to solve for x. It was using the two that were important. Today's lesson is called Special Segments. So if you want to title your notes, it's called Special Segments. We're going to learn about 4 special segments today, and they're no secret. The cat's out of the bag. These are the 4 special segments: perpendicular bisector, median, angle bisector, and altitude. So I gave you 4 pictures of the 4 special segments, and I want to see if you can, in your brain, try to match the picture with the word, just using what pieces of prior knowledge you can puzzle together. Don't say anything yet in the chat. I'll letter them so that I can call on you. I'll letter them so we can talk about it. Eric thinks that A is the perpendicular bisector. Relina thinks maybe B is an altitude. What else you got? Johan thinks that, which one's a median? Which one did I call on for you? C is a median. Try again. Araceli's is a median, yeah. So what's yours, Johan? There we go. Okay. Okay, the lesson's over. I taught you everything. Just kidding. Okay, so here are your segments. Let's talk about each of them. Perpendicular bisector. Perpendicular means there better be a right angle. Is there a right angle there? Yep, there sure is. Right at S, at point S. Bisect means to cut in half. Do you see tick marks? Yep. So it's got a box and it's got tick marks. That's what makes WS a perpendicular bisector. Next one, median. I want you to think median, middle. Median, middle, median, middle. So the median goes through the middle of a triangle. It actually divides the triangle into equal parts, equal masses actually. The area of those two triangles would be equivalent, but we'll talk about that more later. Median, midpoint, median, midpoint. And so C is a midpoint because it's got those tick marks around it. The next one, angle bisector, well, it's going to have arcs, right? An angle bisector is going to bisect an angle. So it better have arcs, and that's what these were right here, arcs. It doesn't cut a side in half, it cuts an angle in half. So you're not going to have tick marks, you're going to have arcs. And then last one is an altitude. Where have you heard altitude outside of geometry? So if you've ever been on an airplane and the pilot comes on, we are approaching an altitude of 10,000 feet, or whatever. That means, and I'm going off on a tangent here, sorry. If this is the ground and here's your airplane, if you're reaching an altitude of 10,000 feet, is it the green segment that's your altitude, or is it the red segment that's your altitude? It's not how far you've flown, right? It's how high you are off the ground. So an altitude, and sorry, that's kind of looks sideways. An altitude is a perpendicular 90-degree segment that makes a 90-degree angle because it's going to be perpendicular with the base or the ground or the bottom. So an altitude is like how far you are off the ground, but it is going to be a 90-degree angle. Have you ever been baking something and it's like it has instructions for you, but then it says for high altitude do this because things work differently when you're at high altitudes like in the mountains? You bake it for a different amount of time, you change the temperature, and so your altitude would be how far you are directly off the ground. Okay. So those are the four segments, and we're going to dive into each of those four segments. So the first one, we're going to talk about them one at a time. Now you want cupcakes. One at a time. First one, perpendicular bisector. It can be a line, it can be a segment, or it can be a ray that's perpendicular to a segment at its midpoint. So the key words are, it's got to be perpendicular, that means it better have a box. And it's got to be through a midpoint. That means it better have tick marks. So a perpendicular bisector needs a box and it needs tick marks. WS is the perpendicular bisector of side DG. Okay? I'm not sure how many people are writing this down, how long I need to stay here. Let's practice drawing a perpendicular bisector of side BC. So it wants us to go to side BC in each triangle and draw a perpendicular bisector. So good. First we would need to find the midpoint of BC. That's how we would draw it. So we would go to BC, we would eyeball the midpoint, we would put tick marks around it, and then we would draw a segment going straight up and down. We would go to BC and we would find what we looks to be the midpoint, and we draw a segment straight up and down. And then we would go to BC and we would try to eyeball the midpoint, tick marks, and draw a segment straight up and down. Now, on purpose, I put three different triangles up here. I put an obtuse, an equilateral, and a right triangle. So notice what the perpendicular bisector looks like in each one. What's unique about the equilateral triangle that doesn't happen in the other two triangles? Oh, well, we'll talk about that later. I didn't necessarily want you to say that it bisects A, but that's the only time the segment actually goes through an angle. In the obtuse one, that segment doesn't go through a vertex. In the right one, that segment doesn't go through a vertex, but in the middle one, it does go through a vertex. And we'll talk later about whether it actually bisects it or not. Okay, so there are two cases when a perpendicular bisector would go through a vertex. The rest of the time, it would not go through a vertex. So what two triangles would a perpendicular bisector hit the vertex for? What two triangles? Which ones are special enough? You got them. Isosceles is special enough, and equilateral is special enough. So if you wanted to write that down, a perpendicular bisector will go through an angle two times, for an isosceles triangle and for an equilateral triangle. How many perpendicular bisectors does a triangle have? How many? Yes, it will, Ganesh. 3, good. It has 3 sides, so it's going to have 3 perpendicular bisectors. All right, the next word we're going to focus on is angle bisector. An angle bisector is a ray that divides an angle into 2 congruent, oh, I don't like parts. Let's do 2 congruent angles. Yeah, parts, that's not a good word for a definition. All right, so we've seen angle bisector. We've seen it multiple times, actually. So this is old news. You find an angle that you want to bisect, you draw a ray, and it's going to cut the angle in half. What I want to stress is that it doesn't necessarily cut the side in half. People get confused and they think that S is the midpoint of DG. But just because it cuts the angle in half does not mean it cuts anything else in half. It doesn't cut the triangle in half, and it doesn't cut the side in half. Okay? Guys, you're off topic. So, if I were to practice drawing an angle bisector from angle A, I would literally just go to angle A, I would draw a ray, and then I would add arc, arc. Angle A, I would draw a ray, and arc, arc. Angle A, I would draw a ray, arc, arc. Angle bisector, simple, simple. Okay, so when would an angle bisector also be a perpendicular bisector? The same 2 things are hidden behind these doors as last time. Isosceles and equilateral are once again our special cases, once again. All right. The next word we're zooming in on is median. Median, middle, median, midpoint. All of those, median, middle, midpoint. They all start with an M. It's an alliteration. A segment whose endpoints are a vertex and the midpoint of the opposite side. So you're going to start at a vertex. You can't just start anywhere you feel like. The definition says you have to start at an angle, and then you go to the midpoint of the opposite side. So this one starts at R. It goes to the middle of OK, and we put tick marks around it. C is the midpoint of OK. Just like all the other ones, a triangle would have 3 medians because you could draw a median from each angle. And next week, we're going to do an assessment where we find cool things about when we draw all the special segments of a triangle. Cool things happen. Okay. Practice drawing a median from A to BC. So what you would need to do first is you would need to find the middle. You would put tick marks, and then there is your median. Do you see how a median is different from a perpendicular bisector? What did our perpendicular bisector look like? It looked like that. So the blue one is a perpendicular bisector. The green one is a median. They're 2 totally different segments, okay? But in an equilateral triangle, they are not different segments. They're the same. And midpoint, tick mark, there we go. So that's what a median looks like. Most of the time, it's not perpendicular to the opposite side unless it's equilateral or isosceles. Oh, does a median bisect the angle? No, no, yes. Cool? It's only going to bisect the opposite side unless the triangle is special. When would a median also be an angle bisector and also be a perpendicular bisector? Dun, 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 dun. Surprise, surprise. I know. I'm blowing your mind right now. Okay. Oh, didn't want that slide, sorry. Last one, zooming in, last segment, altitude. Write it down, altitude. An altitude is the perpendicular segment from a vertex to, oh, wait a minute. It doesn't say from a vertex to the opposite side. It says a vertex to the line containing the opposite side. I wonder why it says that. So write it down and then we'll talk about it. RC is an altitude. It goes from R to OK and is perpendicular to OK. RC is perpendicular to OK. It does have to go through a vertex. So 3 of our special segments have to go through a vertex. Angle, bisector, median, and altitude. The only one allowed to not go through an angle is perpendicular bisector. The height. Very good, Rishi. The altitude is going to be the height when we start finding the area of triangles next semester, yes. So, practice drawing an altitude from angle A. So now you're going to figure out why the definition was worded the way it was worded. Try to draw an altitude from angle A for that obtuse triangle. Do it in your brain. Try to draw an altitude. What's happening when you try to draw an altitude? I'll try really hard. Am I hitting it at 90? No. 90? No. 90? Am I hitting it at 90? Am I hitting it at 90? I can't do it. I can't hit BC at 90. So I'm going to have to extend BC, and then I can draw my altitude from angle A. So that's why it says the line containing the opposite side, because that altitude is not hitting the opposite side. It's hitting the extension of the opposite side. So there's our altitude. That's what it looks like in an obtuse triangle. What does it look like in an equilateral triangle? Super boring. That's what it looks like in an equilateral triangle. What does it look like in a right triangle if I draw the altitude from angle A? If I draw the altitude from angle A, where do I go? So let's summarize what just happened here. For an obtuse triangle, the altitude lies outside the triangle. For an equilateral or acute triangle, it lies inside the triangle. And what about for a right triangle? On, there you go. Sometimes it lies on. Now, if I drew the altitude from angle B, it would be inside, right? But if I draw it from A or C, it'll be on. So out, in, on. Kind of sounds like we're talking about belly buttons. Okay, that's weird. Never mind. Out, in, on. Okay. So we already talked about this. When would it lie outside a triangle? Obtuse. When would an altitude also be the side of a triangle? Right. Right. Okay. Let's practice. I'm going to call on people. Have your answer ready to go. Victor says CD. Anna says AE. And Quan says BF. Yep, best friends. BFF. So this will be on your test where we give you a picture and we ask you to name certain ones. So you do have a few things to memorize before Friday. You have to memorize your polygon formulas and you have to memorize these words. What does median mean? What does the altitude look like? What's perpendicular bisector? So you have some memorizing to do before Friday. Okay, next one. Oh, thank you for asking. You don't understand how it's an altitude. You don't understand how this is an altitude. Okay. So an altitude is a segment from a vertex perpendicular to the opposite side. It's an altitude because it starts at a vertex and it is perpendicular to the opposite side. You're right, Johan. You're right. Quan, did I clear it up or no? SV, very good. Are you? Very good. Are you or aren't you? Huh. Okay, V, what'd you get? Is V here? Okay, Johan took it. I'll put your card back in, Ariana. Yes, the altitude is RQ. Now, could I have put that the altitude is SV? Is SV an altitude? Yes, question mark? So, no, you weren't supposed to answer it, but you did answer it. So anyways, SV is an altitude, but it's also a median. And when something is an altitude and it's a median, you don't call it an altitude, you don't call it a median, you call it a perpendicular bisector. Does that make sense? It's like in the other unit, I think it was, I used it one time with that too. So an isosceles triangle could be equilateral. An equilateral triangle is always isosceles. If you call an equilateral triangle isosceles, you're offending him because he's more than that, he's equilateral. Maybe that's when I said it the first time. I don't remember. But anyways, SV is a perpendicular bisector. You would not name it an altitude. It's an altitude and a median, so it gets promoted to be a perpendicular bisector. All right, let's try some examples. OL is a perpendicular bisector. So what would I do? OL is a perpendicular bisector. What would I add to my picture? Perpendicular means I would add a box, and bisector means I would add tick marks. Good. GA is 12. OL is 8. And angle A is 53. Find LOG, I'll call that X, and OG, I'll call it Y. This problem has a lot going on. Notice that when a perpendicular bisector goes through a vertex, because it normally doesn't, this normally does not go through a vertex. It normally does not. When it does go through a vertex, our triangle is special. So that means this triangle is at least isosceles. It might even be equilateral. We don't know yet. Well, it's not equilateral because of the 53. So it's at least isosceles. So Lars, you were writing that, right? You were going to write isosceles? Anyways, so because the perpendicular bisector is going through the vertex, that means it is isosceles. Since it's isosceles, we know that the base angles are congruent. 53, 53. We also know that GA has been cut in half. And so 12 bisected is 6. This is 6. So we have a triangle right here. And this is 6 and this is 8. And we're trying to find that. And then we've also got that triangle and we know 2 of the angles and you're trying to find the third angle. Does anyone I called on have the answer? Rishi, I didn't call on you. Okay. But OG is 10. And you could get that by doing Pythagorean theorem. Pythagorean theorem. And Ariana X is 37. So you added these up and subtracted from 180. So angle log is 37. So there was a lot of concepts tested in this one problem. Moving on, because I know some of y'all have to go to class. If you have to go, just go. Just go. All right, FM is 6x plus 10. MR is 8x minus 5. And FR is 75. Find X. Is AM a median? So the way you would solve this is you would do segment addition. Part plus part equals whole. So you're not going to assume it's a median. We're not going to set those equal. That would be the wrong way to approach this problem. So we're going to add these together. And we get, woo, beautiful answer. X is 5. Now we need to plug it back in and decide if AM is a median or not. 6 times 5 is 30. 30 plus 10. So FM is 40. 8 times 5 is 40. 40 minus 5 is 35. Is AM a median? The answer is no, because it is not going through a midpoint. Oh, yay, we made it to the end. We have a quiz tomorrow over triangles. Tomorrow is also review day, and we have a test on Friday. So it is a fast and furious short unit. Quiz tomorrow over all triangles, and then test Friday.